In this video, I'm going to discuss permutations and combinations. I'm going to have 5 objects, picking 3 at a time. Different combinations of 3, of course. And I'm going to calculate permutations and combinations and walk you through how those calculations are made. In the previous video in this playlist, I discussed in some detail the differences between permutations and combinations. And it may be helpful for you to watch that video as well. I imagine I have 5 objects. 1, 2, 3, 4, 5. The question becomes, with 5 objects, how many different ways can I organize 3 of them? So I pick 3 at a time. How many different combinations and how many different permutations can I come up with? Picking 3 at a time. I can take these 5 objects and I'll pick 3 at a time. I can use these 3, I can use some in the middle, that one, this one, or that one. How many permutations and how many combinations will I come up with? N is equal to 5, which is the number of total objects. And small n is equal to 3, which is the number of objects I'm going to pick at a time. The calculation for permutations is n factorial, capital N factorial, divided by capital N minus small case n, and all this factorial. The formula for combinations is exactly the same, but I add to the denominator small case n factorial. The only difference in these two equations is the n factorial, that small case n factorial in the denominator. I will calculate the number of permutations first, and this is equal to 5 factorial divided by 5 again minus 3, which is how many I'm picking at a single time, all this factorial. Then in the numerator at the top, I have 5 times 4 times 3 times 2 times 1, which is 5 factorial. In the denominator, I have 5 minus 3, which is 2, or 2 factorial. So I have 2 times 1. Let's make it easy on ourselves. Look for things to cancel. I can cancel 2 times 1 in the denominator and the numerator. It leaves me with 5 times 4 times 3. This leaves me with 5 times 4 times 3, which is simply 20 times 3, which is equal to 60. So these 5 objects, picking 3 at a time, can be organized 60 different ways. Now I will calculate the number of combinations I have. So I will move this over slightly to there. Again, I have 5 factorial divided by the number of objects I'm picking, 3 factorial, which is 3 factorial, times 5 minus 3, and all this factorial. This is equal to 5 times 4 times 3 times 2 times 1 in the numerator, divided by 3 factorial, which is 3 times 2 times 1, and let me slide that over. 5 minus 3 is still 2, so I have 2 factorial. That's equal to 2 times 1, and again I will slide this over to the denominator. I could pound this out in the calculator, but I'm going to look for things to cancel first. Let me slide this over to the left slightly first, like that. I can cancel the 2 times 1 in the numerator and the denominator. And also the 3 cancel as well. This leaves me with 5 times 4 in the numerator and 2 times 1 in the denominator. So I end up with 20 divided by 2, which is equal to 10. It turns out that 5 objects picking 3 at a time, I get 10 different combinations. And I have 60 permutations. So if I take these 3 objects from the 5, so I select these 3, I can make 6 different permutations, but this is only one combination. So this is why we have a lot more permutations than combinations. Permutations should always be greater than the number of combinations, with one minor exception. When the number selected is 1, permutations and combinations will equal each other. Hopefully you can look at these equations and figure out why they would be equal. That will do it for this round of permutations and combinations. Next, I'm going to discuss the statistics of the lottery. Not long ago, the Telegraph reported the lottery is our best hope, say 3 in 10, or 30% of the people are relying on the lottery, which I'm going to show you is probably not a really good idea in the next video. As always, share the knowledge, share the love. Like us on Facebook, Google+, Twitter. Comments and questions below, and as always, subscribe. I'm always posting new things.